Hi guys, and welcome to today's video on converting fractions, decimals and percentages. As if your life isn't complete enough, here you are wanting to learn about converting fractions, decimals and percentages. It's part of the real number section of work for our year 7 to 10 curriculum, and it couldn't be more important to be able to convert fractions, decimals and percentages. In fact, you should already be doing it. Why? Well, whenever we give you test scores, how many of you try and work out whether you got 50% or more? We don't normally always mark tests out of 100, do we? No, we mark them out of all sorts of different stuff. And yet we come up with this idea of percentages, this out of 100 stuff to try and help us. But how? Why has that become important? Well, hopefully I'll explain that to you in this video. And by the end of it, you will also, like me, be a maths guru. Thank you very much for watching. If you're new, can you do me a favor? In the corner, there may be a little doohickey or somewhere a subscribe button to subscribe to my YouTube channel. Greatly appreciate it if you could. It just lets me know you're watching. Never going to be rich, never going to be famous. But actually, if people watch, then it just means I can actually keep recording them because I sort of enjoy it when people are watching. Above me is MaffsGuru.com, where you can find this by textbook and all sorts of other year levels worth of work with downloadable notes. Head on over there. It is a good place to hang out. Would say it was better than House Party. Probably not. What do I know about House Party? So converting fractions, decimals and percentages. We are dealing with building on the last lesson we've had negative fractions. We've known how to add, subtract, multiply and divide them. We know what a fraction is, but I'm going to recap again because surprisingly a lot of people don't seemingly know what a fraction is. And what do I think about fractions? I think about pizza, and I think about chocolate, and I think about KFC, and now I'm getting hungry, so probably let's stop that one there. Now, last night, believe it or not, and this is sort of true, it's not true at all because I can't remember what I had for dinner last night, but let's assume I had pizza. And this pizza, which was bought from Coles, had just 4 slices. It was a very small pizza, and I ended up being very hungry at the end of it. Now, if I ate this section here, what fraction of my pizza have I eaten? Well, I've eaten 1 piece out of the 4 that was there, and lo and behold, there is a fraction. Now, notice the use of the word out of, because it's so important. Out of and divide, basically the same thing. Well, I ate my first slice and then I became hungry and I was still hungry, and so I ate a second slice, which meant I had now eaten 2 out of the 4 slices. 2 slices had been eaten, 4 slices were there to begin with, which, as we know, we can cancel down to 1/2, and yes, it's fairly obvious there that we've eaten half a cake. Half a cake. See, I'm back to cake now. Pizza. Well, my 9-month-old daughter, I decided that, well, she was looking a bit hungry. I'll let her have a slice of that pizza as well. And so, well, by the end of time, or by the time she'd eaten that, we had eaten 3 out of those pieces, 3 out of those 4 pieces, which meant we'd eaten 3/4 of it. And then by the end, I was like, no, I'm sorry, Bailey, you're not having another piece of pizza. That is mine. And so we ate 4 out of the 4 pieces, which is 1. Now, I know this is probably a little bit simplistic for you, but it's important to realize that actually fraction and out of is just a ratio. We've also learned that fractions have something called a numerator and a denominator. This is all language that we throw in to try and confuse you. Now, I don't know whether you know this, but one of the most fascinating things with me is the divide sign. If you look on your calculator, you have a divide sign. Do you know why it's written that way? Because realistically, it's trying to say to you, hello, this is your fractions button. Because basically that dot there stands for a number, there's your other number, your little line, and there's your bottom number. There's your fraction, there's your divide sign. It's just trying to scream at you, hello, I can help, all right? Not bad for a dumb piece of machinery. Now, what is a percentage? I'm going to zoom in just a little bit on this one because I think one of the things we tend to do in maths is we teach you all this theory and all this rubbish and never really give you some real world stuff. So part of the Further Maths course, which is a year 12 course, basically has some really fascinating stuff in it. Not veggie maths in any way, shape or form, probably more real world maths. And here we go. So a survey was done where a number of people were asked 2 questions. Whether they were male or female, now hopefully they weren't asked that question, hopefully it was fairly obvious, but we'll leave that one there, and whether they were for or against gun control. Now, I know at this moment in time, gun control is a big thing. There are so many shootings happening around the world, and I have to say I'm all for trying to prevent people being shot. I don't really care about people's rights to, defend and stuff. It's perfectly okay here in Australia. not to own a gun, and so let's just leave that one there. Now obviously when we look at this table here, what we notice is we have males and females, and we have for and against. So those were our answers, and it turns out that 32 males were for and 30 females were for as well. So it would appear that basically there are equal numbers of males and females who were for. Yes? Well, that's what the data sort of shows, but actually it's lying to you. It's a bit of a trick, smoke and mirrors. Why? Well, look at the number of people who were asked. There were 58 men asked and 42 women asked. So does that make any difference? Well, absolutely it does. When we have different values down here, we can't compare the results. It's not easy for us to compare. So this is why we've come up with this random thing called a percentage. Because what we do is we scale, we change numbers so that they become out of 100. So at this moment in time, if we were to look at male, we have 32 out of 58 actually were for gun control, and 30 females out of 42 were for gun control. We can't compare those numbers in any way, shape or form because they have different numbers on the bottom. But if I could change this 58 into 100 and 42 into 100 mathematically, then life would be awesome. You do this with test scores all the time. Well, as it turns out, the easiest way to turn them into percentages is actually to do the top number divided by the bottom number and multiply it by 100. And what happens when we do that for all of the figures in our table is you'll notice now that we've sort of just changed the bottom of that. So rather than having the number of males and the number of females, what we have, is the number of, all those numbers are now scaled out of 100. They're all percentages now. And what we can see is now 55.2, sorry, using the wrong pen again. Now we can see that 55.2% of males were for gun control, but a lot more women were for gun control in comparison. That wasn't, remember what happened in that previous table where that value was 30 and that value was 32. So percentages are really important to us, and there's lots of ways of writing percentages, converting to percentages, and that's what this video is going to show you how to do. So one of the ways we can do it is use equivalent fractions. So if I had 20 out of 50, for example, well, what I've just said is if we can make the denominator out of 100, then that's effectively what a percentage is. We can do that nice and easy in this situation by using equivalent fractions, because to go from 50 to 100 is actually really simple mathematically because we times by 2. And that's what we've been doing in previous exercises. So if we multiply the bottom of a fraction by 2, to keep it equivalent, we multiply the top, and so that becomes 40 on 100, and whenever we see divide by 100, we can replace that with a percentage sign because it means exactly the same thing. Okay? Easy peasy lemon squeezy? Absolutely. Alternatively, we can use our calculator to turn things into percentages. I'm going to do that a little bit later on. So let's start simply with converting a percentage into a fraction. Basically, we just do what I talked about a moment ago, but backwards. So if I have, as I say here, 23%, remember that percent sign now becomes 23 out of 100. There you go. I have changed a percentage into a fraction by doing nothing more than changing the percent sign into a divided by 100. What about 55%? Well, again, that becomes 55 on 100. Would we leave our answer like that? No, probably not. Why? Because they can both be divisible by 5. Yes, and we would have to cancel down. So cancelling these down, dividing both the top and bottom by 5 gives me 11 on 20. And in fact, that is my lowest value. How do I know this? Well, actually 11 is a prime number and 20 is not in the 11 times table. So there's no way that's going to go any further down. So that's the general idea. Let's do some examples here. Now, thankfully and very kindly, Cambridge have given me permission to use their examples. Yay! And so, thank you very much to Cambridge, good textbook. Convert the following percentages to fractions or mixed numerals in their simplest form. So we're going to turn this into a fraction and leave it as a fraction. So I now have 160% is the same as 160 divided by 100. What am I going to do now? Well, I've got it in a fraction, I have to simplify it. And this is where we come back to number rules. Now I know that because the top number and the bottom number ends in a 0, I can actually divide the top and the bottom by 10. That's going to give me 16 on 10, and life becomes a bit easier for me now. Can't divide by 10 again, but they are both even numbers, so I can divide the top and the bottom by 2, and I get 8 on 5. They're not going to cancel down anymore, and so because the question said all mixed numerals, I know that 8 is bigger than 5, so that goes 1, remainder 3, with 5 on the bottom, so 1 3/5. Job done, loving it, so easy. And then, yeah, we throw a curveball in. Sorry. Same idea, we've got 12.5%, it becomes 12.5 on 100. Now there are two ways of doing this, and we'll come back to the two ways in just a moment. Let's do it the place value way. We are not allowed to have decimals and fractions coexist, not allowed. So what I'm going to do is get rid of that decimal point, and the only way I can do that mathematically is times by the top and the bottom by 10. Why? We go back to place value here. If I want to get that decimal point out and I've got one number after the decimal, I have to multiply by 10. And what we do to the top of a fraction, we must do to the bottom of the fraction to keep it equivalent. So I end up with 125 on 1,000. What do I do now? Well, I start cancelling down. I know that 5's going to the top and the bottom, which gives me 25 on 200. And believe it or not, 5's going to the top and bottom again, which gives me 5 on 40. And I know that 5's going to that again, which gives me 1 on 8. Now, it seems like a lot of hard work, but I'm using basic division by 2 or 5 or 10, and I'm getting the right answer every single time, if I know my times tables, which hopefully I do. So there you go, 1 on 8. Now, the other way of doing this, funny enough, and this is a bit of a trick, and it only works for this specific example, is I can actually double that. So I can think of this as 25 on 200. Now, I've doubled the top, I can double the bottom. 25 on 200, believe it or not, now gets me back here. Simpler, but you would still have to work across to get to that 1 on 8. So that's how to turn a percentage into a fraction, and now we're going to look at turning percentage into decimals. Well, believe it or not, it's sort of exactly the same stuff. We know from previous videos that when we divide by 100, we're really just bouncing decimal points. If we divide by 10 or 100 or 1,000, we're just moving the decimal point. So scrolling up again with some more examples from Cambridge, let's say 723% is the same as 723 divided by 100. Now, it doesn't want me to leave it as a fraction, it wants me to do the decimals. So I tend to rewrite this as 723 divided by 100. Why? Because the minute I see it that way, I know that this is place value. I'm dividing, so my decimal point's going to move that way. I've got 2 zeros, so basically I'm going to jump my decimal point 2 places to the left. So 723, there's my decimal point at the end. Jump it 2 places, gives me the stunning value of 7.23. And so there we go, 7.23. That is a not percentage now, it's a decimal number, so we don't put the percentage sign over. Same with the next example, and I love actually converting percentages to decimals because it's so simple. I've got 13.45% is 13.45 divided by 100. Now I don't need to do all that rubbish I did before because I'm turning it into a decimal. So that's 13.45 divided by 100. Yay, I love seeing it this way because I'm place valuing it. I'm going to move it 2 places to the left. And so I had 13.45. Now they've already got the decimal point in there, so I'm just going to jump it 2 places, which puts it at the front, and so in which case that becomes 0.1345. Now, someone yesterday left a comment on one of my videos saying, look, my teacher doesn't care if I don't put the 0 in front, and actually that's down to individual teachers. But what I tried to explain in my comment back was, to be honest with you, the brain is pre-programmed to miss horizontal signs, minuses, and points. And the smaller those points are, the more likely we are to actually ignore them as a teacher. So for example, in this situation, imagine I had some working out and you just did 0.1345. That's not what my brain is looking for. When I'm marking this work, and teachers make mistakes, I'm not looking for 1345, I'm looking for 0.1345. And in this situation here, I could mark that incorrect because I may think you've made a silly mistake and written 1345. My advice is put that 0 in. It's going to make sure that your teacher and you later on will actually make sure that you see it and hopefully mark it correctly. So converting fractions into percentages now. Notice what we're doing. We're going backwards and forwards from percentages to fractions, fractions to percentages, and blah, 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 blah. Now, the theory here is all downloadable on Notes. So what I'm going to do is just talk about it with some actual worked examples. Now, we want to turn the following fractions into percentages, which means that we've got to try and change this fraction, so that's 3/5, into some sort of number out of 100. Now, in which case, for that particular example, that's nice and easy, believe it or not, because I can turn 5 into 100 quite simply by multiplying by 20. Likewise here, multiply by 20 to keep these equivalents, gives me 60 out of 100, and we now know that where we have divide by 100, I can write that as 60%. Job done? Job done. The problem is not all of the numbers on the bottom of fractions are going to be that nice to me. So if I had 7 on 40, for example, and I tried to turn that into out of 100, now there are ways of doing it, because believe it or not, and strangely, I could open my calculator and say, well, what's 100 divided by 40? And I come up with 2.5. Now the reason I'm doing that is because then I know that that is multiplied by 2.5, which means I'm now going to multiply that by 2.5. Well, 7 multiplied by 2.5 gives me the grand value of 17.5. And that's 17.5 divided by 100, which is 17.5%. Now that is certainly one way of doing it. The other way of doing it is actually using your calculator for what it's designed for. So what first thing I'm going to remember is I know that this is the same as 7 divided by 40. And that gives me 0.175. Now, the rule in maths is if you have a decimal, times it by 100 to give you a percentage. And so, because my calculator is showing me 0.175, I'm going to times that by 100, and that is going to give me 17.5%, which I got a moment ago. So, here we go, ladies and gentlemen. Let's do the let's do the calculator version for this. Oh, I've got 2 1/4. I don't like 2 1/4. I'm going to change that top heavy. So I'm going to do my big number times the bottom number, add the top number. So 489. So that becomes 9 on 4. 9 divided by 4 on my calculator gives me 2.25, which I'm going to multiply by 100 because I'm going from a decimal to a fraction, a decimal to a percentage, times that by 100, and gives me the wonderful value of 225%. 2/3, believe it or not, is a recurring decimal. I know this, and again, builds on the video we did previously on recurring decimals. 2/3. 2 divided by 3 gives me my decimal of 0.666666666. So I'm just going to write that as 0.6 reoccurring. That's the same as what's on my calculator there. And to turn a decimal into a fraction, to turn a decimal into a percentage, I multiply that by 100, which gives me 66.7%, and I'm going to round that to 1 decimal place. Now, there are other ways of expressing this. 66.6 with reoccurring decimal, that's perfectly acceptable, or 66 2/3%. Because again, 0.666 ... that last part of that fraction is the same as 2/3. Any of those, for me, would be totally, utterly acceptable. And finally, I think this is finally converting decimals into percentages. We've funnily enough just done this. So in your summary book, you would be putting to go from a decimal to a percentage times by 100. So I've got 0.458 times 100. Now, yes, I could use my calculator to do this, but again, I've got place value. I'm timesing by 100. So when we divide by 100, we go to the left. When I times by 100, I move to the right. So in which case, that is going to give me, well, I've got 0.458. It's going to jump 2 places, going to end between there. So it's 45.8. And I must remember to put my percentage sign, because if you don't put your percentage sign, sadly, it's incorrect. And finally, 17.5. Same, 17.5. I'm going to multiply that by 100. 17.5. Bounce the decimal 1. two places. Oh, that's annoying. There's nothing there. Exactly. So put the nothing there. So that's the same as 1750 and percent. And I think, ladies and gentlemen, yep, that is it for this lesson. So we started talking about pizzas and we ended up being able to convert between fractions, decimals, percentages and all that malarkey, and I hope it's been useful for you. Please, practice makes perfect. As much practice as you possibly can. At some point there will be worksheets of questions downloadable from MaffsGuru.com, but at this moment in time, let's get the video sorted. If you haven't already done so, can you subscribe? Send out a hello and a sort of promo for me to TikTok, and I would be deeply appreciative. Otherwise, I look forward to seeing you the next lesson or the next video if you decide to come back. Thank you very much. Take care. I look forward to seeing you next time. Bye bye.